Hello, and thanks for using TickBoom. In this question, we're being asked to solve for the intersection of two vectors. And this kind of question comes up in the Extension 2 math curriculum, or the 4-unit math curriculum of the HSC. And it's really asking us to solve the intersection of two vectors that actually sits on a plane that is a combination of the imaginary plane, in this case reflected by the letter I, which is the square root of -1, and then what I'll call the real plane, which in these vectors is reflected by the letter J. So the idea is that both of these vectors will sit on this plane that's a combination of imaginary and real. And just like any other solving of simultaneous equations, we want to know at what point would these two vectors intersect. So there's really 3 steps that you can follow to tackle these kinds of questions. Step 1, I call it distributing I and J. And really what that means is for each of these vectors, rearrange the formula so that you have I and J by themselves outside brackets. So we'll start with vector 1, and that would rearrange to I bracket, and in this case it would be 2 and then minus 2 lambda plus J bracket 3 plus 3 lambda. So you can see all I've done there is just rearrange what we already had. And we'll do the same thing for vector 2, I bracket 6 plus mu plus J bracket, and in this case it would be 2 minus 4 mu. And that's step 1. That just gets us to a place where we can easily see each vector in this imaginary and real framework. So what we'll then do for step 2 is we want to set I and J to be equal for each vector. And essentially what I'm doing is I'm saying, well, the bits next to the I in the brackets for vector 1 and 2, make those equal, and the bits next to J in the brackets, make those equal. So we'll start with I, and that gives us 2 minus 2 lambda is equal to 6 plus mu, and that then means if I bring the 2 lambda over and the 6, we'll get 2 lambda plus mu is equal to -4. And I'll just rearrange for mu by itself. We'll get mu is equal to -4 minus 2 lambda, and I'll call that equation 1. Alright, now let's do the same thing for the J's. So that would give us 3 plus 3 lambda is equal to 2 minus 4 mu. If we rearrange that, I'll just bring the 4 mu and then the 3 over, so we'll get 3 lambda plus 4 mu is equal to -1, and I'll call that equation 2. And just like any kind of solving for equations, I'm going to, in this case, I'll insert equation 1 into equation 2. So insert 1 into 2. So we'll get 3 lambda plus 4 bracket, and for mu, I'll replace that with -4 minus 2 lambda, and that's going to be equal to -1. So that will give us 3 lambda minus 16 minus 8 lambda is equal to -1. That gives us minus 5 lambda is equal to 15. And then that lets us solve for lambda equals -3. Now that we know lambda equals -3, we can insert that back into the formula for mu. And then we know mu is equal to -4 minus 2 times -3. And that gives us mu of 2. So that's step 2 done. Now the final step, step 3, what we want to do is calculate I and j for each vector. And essentially that will give us the point of intersection. We'll do it for both vectors, but in theory we should get the same value of I and j. If we've done our job properly here, we will effectively demonstrate that it is truly the point of intersection. So I'll start with vector 1, and we'll do I first. So I is equal to, in this case, 2 minus 2 lambda, which equals 2 minus 2 times negative 3, and that gives us 8. And for j, that is 3 plus 3 lambda, which equals 3 plus 3 times negative 3, and that gives us negative 6. Alright, so in theory we're getting the intersection at the point 8, negative 6, but let's check that by making sure we get the same thing on vector 2. So here we'll have I is equal to 6 plus mu, which equals 6 plus 2, mu is 2, which equals 8, good, and j is equal to 2 minus 4 mu, which equals 2 minus 4 times 2, and that gives us negative 6. So that gives us the confidence that we haven't made any mistakes in our solving. And so you can say, therefore, V1 and V2 intersect at the point 8, negative 6. And that's the way to tackle these kind of questions. So hopefully you found that helpful. And tick boom.